Hey, my name is Marten Fadi, and my topic is Design and Construction of Truss Bridges. Introduction. I chose this topic to research as my semester 6 technical report because truss bridges are very special bridges and need someone to show how beautiful they are. I intend to demonstrate in this report how steel get used as significantly as concrete, but still as loveliness to the developments as well. The importance of learning how truss bridge is made is very beneficial. Concrete and steel are everywhere. The history of truss bridges is very amazing and will blow your mind once you learn about it. These types of bridges have been unique and beneficial to our world. And here is a truss bridge. History of truss bridges. When people talk on historical bridges, they really frequently see covered wooden truss bridges. In addition, along with its stunning design, the wooden bridge includes a near universal appeal. For numerous years, travelogues and historians similarly have recognized them and supported their conservation, quite the other bridge type. For centuries, engineers used timber as a building materials for trusses, perhaps even for truss bridges. However, it had been not until 1570 that Palladio published 4 books on architecture, the main author documented concerning about wooden truss bridges. Moreover, builders in Europe erected few wooden truss bridges until the 18th century, then most ordinarily and heavily wooded countries like Switzerland. And here is a truss bridge in Switzerland, very old bridge. Warren Truss Bridge. Students and books have commonly called the truss with rotating compression and pressure diagonals a warren, even though sometimes it is called asymmetrical truss bridge because each board length and diagonals are comparative length, making a cycle of equilateral triangles. Once the length of the span rises and the height of the truss also rises, it makes the lengthy compression members, which are within the highest joists, rise too. Most common Warren truss bridge is this one, and this one is a Warren truss with vertical support. Warren truss bridge. Also, it needs exceptional bracing because we need to reduce buckling with the vertical direction. Moreover, the verticals stay located from the lower stored panel points to the center point of the major chord member, which will eventually go directly past it. Also, once all that is done, the deck building stringers start to get along, which requires stronger members. And here is a Warren copyright sketch showing deck at both heights. Pratt truss bridge. A Pratt truss consolidates vertical individuals and diagonals that its inclination brings down towards the center and the backward of the Howie truss. In comparison, the inner diagonal parts are underneath the pressure, underneath the change load, even underneath vertical segments pressure. Meanwhile, if unadulterated pressing factor parts are used inside the diagonals, for example, I-bars can end up in intersection segments and might be necessarily to close the middle of it to recognize the thought live loads as they explore the range. And here is a Pratt truss and even numbers of panels. Howie Truss Bridge. Howie Truss Bridge is a very good bridge plan that was created by an American modeler named William Howie. Also, it uses very close arrangements. For example, the Pratt truss with a strong differentiation. However, the slanted fundamental bars slant toward the bridge place even though the Pratt truss uses slanted bars that slant outward from the focal point of the scaffold. Lastly, this methodology makes slanted individuals of Howie truss get along in pressure, while the vertical web individuals are in strain. And here is a Howie truss diagram. K-truss. The K-truss plan was a good selection to use after the Parker truss plan. Also, the Parker ended up pursuing the Pratt truss. Moreover, the K-truss can separate the vertical individuals into tinier territories. Nevertheless, since the vertical individuals are under pressure, it is more limited into a section because it can tolerate the upend to collapse from pressure. Lastly, we should know that the K-truss is likely to be an intricacy because it did not have the chance to be outstandingly common inside the joined together states. And here is a K-truss in Oklahoma. Bridge classification. Vehicular bridges are very important because they support many vehicular loadings. Also, there are several circumstances that the vehicular bridges support. For example, they support off-road and recreational vehicles, such as snowmobiles, ATVs, equestrian loads, and extra. Any bridge observation platform or tower that is subjected to pedestrian, equestrian, ATV sky, and snowmobile traffic is taken into account as an overcrossing because this is very important. And here is a vehicular truss bridge called Blackfriars Street Bridge. Bridge design consideration. Aesthetics. Truss bridges can improve the field view of a setting, and it can make the street all the way through a recreation center that is desirable over the standards. It can even be more efficient in designing buildings. Structure arrangement. Most of the time, the medium-span bridges tend to use a lot of single-path structures that contain truss bridges and sometimes even cable bridges. Durability and materials. The Canadian Highway Bridge Design Code can give the new buildings maintenance for like 75 years. And here is an aesthetic of truss bridge design. And here is a structural arrangement for truss bridge. Bridge design consideration. Culverts. You must know that the designers are going to examine the culverts because we must utilize the bigger culverts just to place them in structures such as standard. Bridge barrier systems. Just like the plan that is directly above its limits, the bridge systems that got barriers. A lot of parks in Canada have importance for cultural and historical holdings. Also, it could be a required design to do because we utilize the non-standard tools and hydraulic line motors, and even masonry. And here is a truss bridge on top of culverts. And here is a bridge barrier system railing for truss bridge. Loads. There are pedestrian loads and vehicular loads. We need to take those in measure because we need to make sure that everyone is safe and the loads are very, very, very good. Design. Loads. You must know that certified engineers will design Class A bridges and vehicular that are accordant along with the CHBDC. Railing loads. An agreement with CHBDC, it will be the vehicular bridges that include railing loads tend to have a huge impact on the bridges. Bridge barrier system. The vehicular bridges utilization of the accident tests of railing structures are identified by CHBDC. And here is a railing requirements table. Inspection. There is a standard that we must follow, so it's very important to do inspections for bridges. We must make sure that everyone who goes through the bridges is comfortable and safe, such as we must offer a rate of decline and a constant recording of the situation of the building. We must start the protection for the activities. And here is a historical rehabilitation of Ohio Bridge. Kinds of inspection. Comprehensive detailed inspections, routine maintenance inspections, visual detailed inspections. If you want to find more details about those inspections, you may go to my written report and read it from there. Plan for your home inspection. Calculating the truss bridge. Forces, trusses, and joints. The way that each joint bear can be characterized through a force, we call a force for a reason, because every single joint is weight characterized by a force. Analysis of forces. After all the forces that perform upon an object are stable, that means it can be in equilibrium. Applying the sigma notation to signify the total, the equilibrium circumstances can be able to be precisely written as Fx equals 0 and Fy equals 0. And here is a diagram of simple truss showing forces and joints. Calculating the truss bridge. So here we calculate the forces for Fy and Fx for each node, and then we calculate the compression and tension for each node to make sure if this node is compression or tension, this other compression or tension, and so on. And all those are called free body diagrams for the analysis of forces at truss nodes. Conclusion. Through centuries, the truss bridges have been used effectively. They are unique bridges and need someone to show how beautiful they are. In this report, it showed you that steel get used as significantly as concrete, but still adds loveliness to the development as well. We learned the importance of learning how truss bridge is made is very beneficial. Concrete and steel are everywhere. The history of truss bridges is very amazing. These four types of bridges have been unique and beneficial to our world. The design process was overall easy to understand. They showed basic steps on how truss bridges get built by only using simple formulas. Thank you for listening and watching my presentation.